Hi guys, this is lesson 5.1, solving inequalities by addition and subtraction. In this chapter, instead of equalities with equal signs, we're going to be doing inequalities, and we're going to see signs like this. A lot of what we're going to do is using the same skills that you've already been practicing. There's only a few details to have to pay attention to that are different in inequalities. So here are the signs that we're going to be talking about. Whenever you see a sign that looks like this, I like to look at it from the left to the right, and this one starts with the pointy. So this is a less than. We'll see things like fewer than 5 marbles or something like that when we see a word problem. When we see this sign, if you look from left to right, it starts with the fat side. This is a greater than. And we will see things like more than 10 dogs. If you see this underneath either one of those symbols, it means the same thing, and then add on this or equal to part. So this is a less than or equal to. This is a greater than or equal to. And you'll see words like at most or no more than. It means that you can actually have that number, but in this case, fewer than that number also. And in this case, if you have at least or no less than, it means that you must have that number or more than that. Let's work a couple problems and I'll explain some things as we go. I'm on page 288, and number 1 is a simple little problem. We have x minus 3 is greater than 7. And we're going to treat this nearly as if it was x minus 3 equals 7. So if we were just solving this problem, we would add 3 to both sides. That's called the addition property of equality. If we add 3 to both sides over here, that's called the addition property of inequality. So just one different word, same process. Here I would end up with x equals 10, and here I would end up with x is greater than 10. Now make sure that you keep track of the sign, okay? If you, in this problem, were just to tell me 10, there is only one number that answers that problem. 10 minus 3 equals 7. And so 10 is fine. It's better to write x equals 10, but I would know what you meant if you just said 10 to me. Over here, it's a problem. You need to say x is greater than 10 because x doesn't even ever equal 10. It might be 10.1 or 11 or 20 or 50 or 5 million, but it's a lot of numbers. So make sure that you keep the sign that goes with that. Let me show you a couple ways that we write these answers. Sometimes in a set, people write it out like maybe you might write all numbers greater than 10. That's probably the worst way to have to write it because it's long. This way is called set builder notation, and you end up with the variable like that, and then a line, and then your little expression like this. And we would read this, the set of all numbers x such that, so I say x such that x is greater than 10. And so that's called set builder notation. The other way we do this a lot is we draw a number line, and oh, that's weird, huh? Anyway, I like to keep the number lines really simple, so let's just put a 10 on there. Because this is just a greater than sign, not a greater than or equal to, we're going to use an open circle. That means we're just not going to color it in. It's a way of showing that we don't ever use 10 as one of our solutions. X is greater than 10. So that's the way we would show that. All of the numbers out here are numbers that work in this equation. Let's pick one. Let's say 100. 100 minus 3 is greater than 7. Well, yeah, it is. 97 is greater than 7. So that's true. And numbers out here don't work. So let's say we pick 0. 0 minus 3 is not greater than 7. So that's a true statement, how we drew it. All right, let's do number 8. It says 8n is greater than or equal to 7n minus 3. And I'm going to solve this almost as if there's an equal sign. I want to get my n's together, so I might subtract 7n from both sides. 8n minus 7n is just 1n. Then make sure to keep your greater than or less than sign. And the end answer is n is greater than or equal to -3. Let's go ahead and look at that on a number line. Here's -3. No, it's a very cheap number line. It only gets one number. If you want to spend the time to put a lot of numbers on there, that's your business. All right, so at the number, because n is greater than or equal to, we're going to color in the dot this time because n can be -3. -3 is definitely greater than or equal to, because it's equal to -3. And then again, n is greater than, so I'm going to go this way. All right, I want to show you one where sometimes, let's say we were doing number 4, and I have 11 is less than or equal to p plus 4, and I'm going to subtract 4 on both sides, and I get 7 is less than or equal to p. Now, I don't like it when the letter, the variable, is on the right. It's confusing for me that 7 is less than or equal to p. So here's what I like to do. See how p is on the same side as the fat side? As long as I keep p with the fat side just like that, see? I can flip this around. So p is greater than or equal to 7 means the same thing as 7 is less than or equal to p. And it's a little bit easier for me to understand. So here's what it looks like on a number line. It does or equal to, so we're going to color in the dot, and p is greater than, so it goes this direction. Let's do one word problem here. Number 9. Twice a number increased by 4 is at least, it's at least, so it can equal it, it's at least, but if it's at least, that means it could be bigger than it too. 10 more than the number. All right, twice a number increased by 4 is at least 10 more than the number. And then I can solve this. So let's get our n's on one side. 2n minus 1n is 1n. The n minus n canceled. I have 10 right there. And then I'm going to subtract 4 on both sides. N is greater than or equal to 6. That's perfectly good. For some reason, there's lots of greater thans going on in our answers, but we are going to color in the dot because it can equal 6. It has that little extra line, and n is greater than, so it goes that direction. And I'm going to name my number line n. One thing I wanted to tell you, if you go to YouTube and you search 5-1 solving inequalities by addition and subtraction, you will get more videos than you could ever watch, I think, by other teachers teaching out of the same textbook. So if ever you just want to hear a different voice, explain things differently, you just want to hear it again, just search the lesson go ahead and search even the number and whatever the lesson is called in YouTube, and you'll get a whole stack of videos that you could sort through and maybe pick one that you like, one that's the length of time you like, or a voice you like, or maybe someone that makes great sense. Sometimes I look through those and I try to find one that maybe I think does a good job, but you are welcome to do that. That's a backup for you. You can always get almost a second opinion. So that's there for you.